We're going to take a look at functions and models now. Before we get into any of the example problems, I want to do a little bit of terminology and notation. So we see here this is called business functions. There's 4 basic business functions that we'll use in this class. Capital C of X is called the cost function. So you see it represents the total cost of producing however many items. Capital R of X represents the total revenue when X items are sold. So the difference in these two things is this. Now keep in mind this is from the business's perspective. Cost is any money going out of the business. So you've got to pay your workers, you've got to buy material, you've got to have a place to work, so rent or whatever. Revenue is the opposite of that. That's all the money coming into the business. So if you're charging $100 to sell a certain product and you sell 5 of them, you've made $500 in revenue. Capital P of X, is the profit function. So that's going to be, in essence, the difference between the revenue and the cost. If revenue is all the money you're bringing in and cost is all the money you're putting out, whatever the difference between those is how much you actually make in profit. And then they have lowercase p of x or capital D of x, which represents the demand function, also called the price function. We normally probably don't think of price and demand really being the same thing, but mathematically, as a function or an equation, they are the same. So you'll see our book uses both notations, lowercase p or capital D. Now with these 4 functions, there's a couple important formulas, relations, if you will, that you need to remember. Okay. Profit equals revenue minus cost. P equals R minus C. So again, we kind of said that already. Revenue is everything coming in. Cost is everything going out. So if you take all the money you've brought in and you subtract all the money you've put out, whatever's left over is your profit. It is possible for profit to be negative. If you haven't brought in more than you've spent, then your profit would be negative. So it is possible for profit to be negative. And then we have a formula for revenue down here. If you're given a price, which was again lowercase p of x, or sometimes written as demand function, capital D of x, all you've got to do is multiply by how many items you sell, and you have your revenue. So if you're selling a product again that costs $100 and you sell 5 of them, well, X is 5. So you'd have 5 times 100 is $500 in revenue. So simply multiplying the price times X can give you a revenue function. Okay, now we can start looking at some example problems here. Number 1, it's been determined that the cost of producing X units of a certain item is 10X plus 315. The demand function is given by lowercase p equal capital D of X equal 50 minus 0.25X. They're asking us to find the revenue function and the profit function in the 2 steps here. So let's start with step 1, the revenue function. Okay, so again, I gave you a formula on the last screen that said revenue is X times price. Okay, well, again, they've given us a price function right there. All we've got to do is substitute. Go ahead and multiply that out. All right, so there it is. Revenue function, 50x minus 0.25x squared. All we did was we took a price function, 50 minus 0.25x, and we multiplied it by x to get to a revenue function. And then step 2 is the profit function. So if you look at what you have now, you just figured out the revenue function in step 1. And up here, they're talking about cost is 10x plus 315. So that's the cost function. So we have R and C, revenue and cost. So we can use that formula, profit equals revenue minus cost, to get a profit function. Okay. So profit function will be the revenue function right here, 50x minus 0.25 x squared minus the cost function. Cost function is given up here as 10x plus 315. Now do notice I used parentheses here because it does say minus the cost function, so that's minus the entire thing. Not just minus the first term, but minus the whole thing. So minus all of that in the second parentheses. And then to get your final answer, go ahead and combine like terms. Okay, I typically like to write in descending order. So I'm going to write my x squareds first of negative 0.25 x squareds. Then I want to do my x's, so I've got 50x minus 10x. That's going to be 40x. And then my constant, don't forget to distribute your negative sign, so minus 315. Okay. So it's fairly simple to manipulate back and forth between the different types of functions. If you have price, you can get revenue by multiplying by x. And if you have revenue and cost, you can get profit. All right, question 2. Find the break-even point or points for the revenue and cost functions below. Separate multiple answers with a comma. Okay, so what's a break-even point? Okay, so we've already talked about cost is all the money going out and revenue is all the money coming in. Okay, so let's say if your revenue is $100, you've brought in $100 into the business, and at that same time you've put out $100 in cost. So you had to pay out $100, but you got back $100. So your overall profit is 0 at this point. That's where you break even. Okay? So break even is in essence where revenue and cost offset. That's where they equal each other. Or you could say it's where the profit equals 0. Okay? So let's do this here. So if we just set the revenue equal to the cost, we'll be able to solve for a break-even point. So revenue is 10x, cost is 8x plus 30. 10x minus 8x is 2x, equals 30. Divide by 2. X is going to be 15. So in essence, what they're saying here is whatever this product is we're selling, we've got to sell 15 of them to break even. If we only sell 10 of them, we're going to lose money. Our profit's going to be negative. We sell 15 of them, we break even. And then if we sell more than that, we sell 16 of them or more, we're actually going to start making positive profit. Okay, so it's kind of like for a business, I guess you could say it's a goal. You definitely want to get to your break-even point and ultimately pass it so that you're making money. Here in question 3, it's the same kind of question, just uglier functions. So notice, look at the revenue function here. You've got an x squared in there, and you've also got these ugly decimal numbers. But it's the same question. So let's start off the same way. Let's set revenue equal to cost. So revenue is 49.8x. And since these other numbers are in decimal form, I'm going to go ahead and change 7/10 to 0.7. So minus 0.7x squared equal 19x plus 181.3. All right, so again, you've got a squared in here, an x squared. That means this is a quadratic equation. You learned several different ways to solve those in algebra. And the way you chose which method to solve it kind of depended on how the function looked. When I've got these ugly decimal numbers like this, personally, I'm going to immediately jump to the quadratic formula. I'm not going to worry about trying to solve by a different method. So we've got to remember what the quadratic formula was. So I'll go over here on the side. You need to have your quadratic equation in the form ax squared plus bx plus c equals 0. Okay, so let's go ahead and get our equation in that same form. So I've already got my x squared on the left side. I'm going to leave it where it is, negative 0.7x squared. Then I need my x terms on the left side. I've got 49.8x already on the left, and I've got 19x on the right. So I've got to subtract 19x over. So 49.8x minus 19x is going to be 30.8x. And then we have to have our constant over on the left as well. So let's subtract 181.3 over to the left. So as you can see there, you have your quadratic equation in the form ax squared plus bx plus c equals 0. So in other words, a is going to be negative 0.7, b is going to be 30.8, and c is going to be negative 181.3. Alright, now what is the quadratic formula? So again, this is what we need to remember. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll take a, b, and c and plug it into this formula, and we'll be able to find our values for x. Okay. So negative b, so that's negative 30.8, plus or minus the square root of b squared, so that's 30.8 squared, minus 4 times a is negative 0.7, times c is negative 181.3, all over 2a, so 2 times negative 0.7. And let's go ahead and get our calculator out and start simplifying here. So negative 30.8 plus or minus, let's work under that square root sign. So I've got 30.8 squared minus 4 times negative 0.7 times negative 181.3. That's 441 under that square root sign. And then on the bottom, 2 times negative 0.7 is negative 1.4. Alright, if we go ahead and do the square root of 441, it comes out to a nice whole number, 21. You'll notice the problems we've given you, that square root's going to work out to be a nice whole number. If this were the real world, would that happen? Not necessarily. I mean, you could always get a decimal, but we've kind of got them where they work out cleanly, just for the purposes of this class. All right, and then we need to do this arithmetic here. So notice again, there's two answers. There's a plus or minus in there, so you've got to do both of them. Let's start with the plus. So negative 30.8 plus 21. Take all that divided by negative 1.4. Okay, and I get 7 with that calculation. And then we need to do the minus. Okay, so negative 30.8 minus 21. Take that divided by negative 1.4, and I get 37. Okay, so I have two break-even points, 7 and 37. says up here in the directions, just separate multiple answers with a comma. So 7 comma 37. If you answer 37 comma 7 on Hawks, it will accept that too. It doesn't matter what order they're in. So we actually have 2 break-even points on this problem. Okay, and then the last question that we're going to do in the video here, question 4. A clothing manufacturers determine the cost of producing t-shirts is $2 per t-shirt plus $1,260 per month in fixed costs. The clothing manufacturer sells each t-shirt for $20. And they want us to go through in step 1 and get a revenue function, step 2 get a cost function, step 3 get a profit function, and then find a break-even point at the end. So sort of a combination of the previous few questions that we've worked all together. So let's start with step 1, the revenue function. So remember, you've got a formula. Revenue is X times price. Okay. Do they give us a price function? Well, they don't give us the function, but they actually give us a price. That last sentence there, they're selling these t-shirts for $20. The price is $20 is what that's saying. So all we've got to do is say X times that price, X times 20, or in other words 20X is going to be our revenue function. Okay, so not bad. Just multiply the price times X. Step 2, the cost function. All right, we've got to be a little more careful here because notice in the first sentence it says the cost of producing t-shirts is $2 per t-shirt plus $1,260 per month in fixed costs. You've got 2 different costs there. $2 per t-shirt, that's what you would call a unit cost or a per item cost. So the idea is if they only sell 1 t-shirt, then they've only got to make 1 of them, so it only costs them $2. If they sell 5 t-shirts, then they've got to spend that $2 5 times, so it costs them $10. So it's a variable cost. The $1,260 per month in fixed cost is, again, they're referring to it as a fixed cost here. What a fixed cost is a cost prior to any sales. So it doesn't matter if you don't sell a single item, you've got to pay this $1,260 every month. Easiest example that I could give you for that would be rent on your building or your mortgage payment. Even if it's paid off, you're still going to have a tax payment or something. Okay, so you're going to have some kind of building fee every month, no matter what. You could also throw, you got to have electricity and water. Okay? Those are all going to be fixed costs. Doesn't matter if you sell anything or not, you're still going to have to pay those bills. Okay. All right, so to create the overall cost function, I'm going to give you sort of a generic formula to use here. Simply going to be any of your fixed costs plus your, again, I called it unit cost or per item cost. Sometimes you'll see books refer to it as a variable cost. Take that unit cost and multiply it times X, because X is how many you produce or sell. Okay, so in our case here, C of X is going to be $1,260 for the fixed costs plus $2 for our unit cost times X, so that's going to be 2X. So $1,260 no matter what, plus $2 for every item that we produce. All right. Step 3 is your profit function. Well, at this point in step 1 you got revenue, step 2 you got cost. So remember, profit equals revenue minus cost. So our revenue is in step 1, 20x, minus our cost we got in step 2, 1260 plus 2x. Go ahead and combine like terms there. So 20x minus 2x is 18x, and then minus the 1260. Okay, and then lastly, in step 4, the break-even point. So in questions 2 and 3, what we did is we took the revenue function and the cost function, we set them equal to each other, and solve for x to get the break-even point. You could do that here if you wanted to. You could say 20x equal 1260 plus 2x and solve that for x. That would work. But since we've already figured out the profit function in step 3, we could just use that. In essence, the break-even point's where the profit equals 0. So I could just let the profit equal 0 in that function, and I can solve that for x. That gets me to the same place. So let's see, you'll take negative 1260 divided by negative 18, and you get 70. Alright, and this is a basic overview of the 4 business functions that you're going to see in this course. So good luck on your assignments.